Hi everyone, welcome to Tuesday, your second video lesson for maths. And today we're going to be looking at finding the angle or the radius if we're already given the sector area. So yesterday we learned how to find the sector area if we knew the angle or radius, so now we're working backwards. So just a reminder from yesterday, our formula was the area is equal to the angle over 360 degrees multiplied by pi multiplied by the radius squared. Oh, I thought you were going to see that better, but no. So let's have a look at example 1 here. So we're told that the area is 45 square centimetres. We can see that the radius is 6 centimetres and we don't know what the angle is in the middle. So that's what we're trying to find just now. So this is an example on finding the angle. So I'll go through it and then you can pause the video and you can copy it down and then you can try the one for you as well. Okay, so we always start with our formula. So we know that it's area equals angle over 360 times pi times the radius squared. And we're going to fill in everything we know at the moment. So I know that the area is 45 square centimetres. I don't know the angle, so I can keep that as x or I can keep it as a question mark. And I'm multiplying it by pi and multiplying it also by the radius squared. And I know that the radius is 6 centimetres. Okay? So I now need to somehow rearrange this. Colour pen. So I know here that my 360 is dividing on the right hand side of the equation. So in order to get rid of that, to get rid of the fraction, I need to multiply throughout by 360. And that'll give me 45 multiplied by 360, and that's equal to the angle multiplied by pi multiplied by 6 squared. Now, obviously I need the subject of my formula to be the question mark, which is the angle at the moment. And it's currently being multiplied by pi and 6 squared. So I'm going to need to divide both sides of the equation by pi multiplied by 6 squared. So I know then that my angle is 45 times 360, all divided by pi times 6 squared. And then time for my calculator. Making sure you're using the pi button and the fraction button if you wish. Making sure also you're using the square button to keep things faster. And it's an angle, so we normally round to one decimal place, so 143.2 degrees. So just now I would pause the video, and if you take that example down in your notes jotter, and then you can try the your turn one. And when you come back, we'll go over the your turn first and then we'll do a second example. Okay, so by now folks, you should have copied this one down in your notes jotter and tried this one as well. So I'll just go through this for you to make sure you've got the right answer. So always starting off with our formula. Filling in everything we know. So we know that the area is 12 square centimetres. Still got an angle over 360 multiplied by pi multiplied by 5 squared. 360 is dividing on this side, so we need to multiply throughout by that. Oh, you can't really see this green very well, can you? Usual story. Not better? Yep. So 12 multiplied by 360 is equal to x multiplied by pi multiplied by 5 squared. We need x to be the subject of our formula, so we're going to divide throughout by pi times 5 squared. We need to do that to both sides in order to keep the equation balanced. So x is equal to 12 times 360 times pi times 5 squared. Just fit that in and no more here. And our answer should be 55.0 degrees. Again, just one decimal place because it's an angle. Now I know it's 55.00, so it could just be 55, but we want to keep it as accurate as possible. So that's why we're still using one decimal place. Right, so let's look at another example this time. Oops, things are falling over here. Where this time we're trying to find the radius, or it could be the diameter as well. So we've got an example of every type that we could come across. Okay. Get the board back to how it was. Right, so this is finding the radius. Okay. Okay, so here's my sector, and I'm telling you this time that the angle at the centre is 192 degrees, and the area is 20 square centimetres, and we want to find the radius. Okay. So again, we'll go through this one together, and you can copy it down in a wee minute. Okay, so always starting with your formula. Okay, so area equals x over 360 multiplied by pi times the radius squared. Now we know the area is 20 degrees. Sorry, not 20 degrees, 20 square centimetres. We know the angle this time as well. That's 192. Okay. And we've still got this 360, which is dividing on the right hand side, so I need to multiply throughout by that to eliminate that fraction. So 20 multiplied by 360 is equal to 192 times pi times the radius squared. Now obviously I'm trying to find the radius this time, so it is currently being multiplied by 192 pi. So I need to divide throughout by that. So r squared is equal to 20 multiplied by 360 divided by 192 times pi. But you'll notice as well, second year, that this is r squared. So remember, the opposite of squaring something is square rooting it. So that means we need to square root both sides. So r is going to be equal to the square root of 20 multiplied by 360 divided by pi, 192 times pi. Okay, again, getting your calculator. Square root, just going to use my fraction button here and make it easier. And it's a length, so I'm going to use 2 decimal places. So it's 3.45. We were working in square centimetres for the area, so it's centimetres for the length. Okay, so I'll put one up for you to try as well. So this time we've got 100 degrees and I'm told that the area is 10 centimetres. Okay. This time we'll find the diameter. Why not? Right, so at this point it would be a good idea to pause the video and copy down the example that I've gone through and then try the your turn question and then we'll come back together in a wee second and we'll go through the U-turn and make sure that you've got that right before you go on with the exercise. Okay folks, so hopefully you've copied that down in your notes jotter and you've managed the U-turn question as well, like I'd said. So I'll go through this to make sure everyone knows what they're doing before you go on with the questions. So again, formula, always the first thing we write down. And now we're going to substitute in everything that we know already. So I know that the area is 10 centimetres, square centimetres. X is the angle, that's 100 degrees. So 100 over 360 multiplied by pi times the radius squared. Now I'm looking to find the diameter this time, and you know that the diameter isn't involved in this formula, but we do know that the diameter has a direct relationship with the radius, so we can use that in a wee minute. Okay. I'm going to multiply throughout here by 360. And I get 10 multiplied by 360 is equal to 100 times pi times the radius squared. Now I need the radius to be the subject of my formula, so I'm going to divide throughout by 100 pi. So the radius squared is 10 multiplied by 360 divided by 100 pi. And I know that the opposite of squaring something is square rooting it. So 10 times 360 over 100 pi and square rooting all of that. Okay. So putting that into my calculator. And that gives me 3.3851, and it keeps going. Now I know then that my diameter is twice that. Okay, so that's 2 multiplied by 3.3851, whatever it is. Okay, and that gives me 6.77 centimetres and 2 decimal places there as well. Okay. So hopefully you've managed to get the U-turn example correct, folks. If you've got any issues at all at any point, don't hesitate to ask me on our Teams page. I'll be more than happy to answer that. I'm not doing much else anyway. And today you should be working on page 7. Okay. Now you've got all the booklets, you've got the answers and everything there. So just make sure that you're trying some of those. See you tomorrow.